SiteMaster distribution is a monster of complexity, but in about 15 minutes, you're going to be prepared to tame the monster. This isn't just a demonstration. You're going to learn the functional details of how this process works, and with that foundation, you'll be prepared to diagnose process failures. The premise is that retail SiteMasters are only created and maintained in your development, customizing golden client, and then distributed from there to all downstream systems and clients that require SiteMasters. You adopt SiteMaster distribution as a master data process because you recognize that retail SiteMasters are customizing. By implementing this architecture, you're treating SiteMasters as customizing. Data Replication Framework, or DRF, is the standard functionality that enables SiteMaster distribution. Setting up the process is a cross-functional team effort, but the master data expert leads the way. You should expect to cross-functionally orchestrate the technical setup, and you should expect to explain the end-to-end process to everyone involved. To do this, most of us will reach beyond our functional comfort zone. Reach as far as you're able. The more you know, the better prepared you'll be to diagnose the process when it fails. From a business process perspective, think of SiteMaster as a single business object, comprised of many technical objects. That includes site customizing, a business partner, a customer master, a vendor master, and much, much more. When you hear the word site, you understand this to mean the entire collection of objects. But from a technical perspective, SiteMaster is cleanly split into two groups of objects, which can be understood as customizing and master data. Each group is distributed as a distinct step in the SiteMaster distribution process. Business partner, the master data, is distributed first, followed by the retail site, the customizing. A replication model defines the two-step process. It defines the where, what, and how the SiteMaster will be distributed. Because the replication model defines the where, the target business systems, you'll create several of them. For example, let's say that you want to distribute SiteMasters from the customizing golden client to development data migration and development unit test clients, but separately. You'd create two replication models, one for each target. Both clients and quality might be one distribution, so that's another replication model, and so on. You create a replication model for each logical grouping of recipients. The replication model defines what will be distributed. You're distributing two groups of objects, master data and customizing, in that sequence in two steps. Each step has a so-called outbound implementation, which defines technically how the data will be distributed. Let's walk through the concept of creating a replication model to distribute SiteMasters from D41-100, a customizing golden client, to P41-500, a production system client. After defining the target business system, two outbound implementations are assigned, with a sequence indicated. First, the site business partner will be distributed, then the retail site. That's two steps in sequence. Each of the outbound implementations has a technical name, which you'll specify when executing each step. Outbound implementation 986.3 is used for business partner, and site out is used for the retail site. For each outbound implementation, you have to specify the technical method, the so-called communication channel, in configuration of the replication model. But you have no choice in the matter. For business partner, you must select replication via services, and for retail site, you must select replication via RFC. It's very clear that you're dealing not only with two distinct steps, but two completely separate data distribution technologies. We're not going to dig into the details of the technical setup. That's another book. But from a functional perspective, there are some things you need to know so that you can effectively troubleshoot when the process fails. For example, separate SAP user accounts are created for each communication channel. There's an SAP user ID for the web service used to distribute the business partner in step 1, and there's a separate SAP user ID for the RFC destination used to distribute the retail site in step 2. You want to know those two SAP user IDs. If distribution fails in either step, you can use T-code SU53 to check for authorization failures for the relevant SAP ID. You'll want to run SU53 in both the source and the target business systems. Business partner key mapping is used to control site master distribution. This might sound like a tangent, but it's really a key concept. The good news is that in normal operation, you don't need to think about business partner key mapping. Not at all. That's because key mapping entries are created automatically during business partner distribution via DRF. But here's the thing. Key mapping entries are created automatically, but only if the process executes correctly. You can't understand site master distribution, and you can't troubleshoot failures in site master distribution without understanding business partner key mapping. As context, remember that a best practice in SAP Retail is to number site number, business partner number, ERP customer number, and ERP vendor number as all the same number. But this isn't a technical requirement. The identifying numbers for each object could be different in each business system if we so desired. Therefore, the system doesn't use any of those numbers for BP distribution. Instead, all of the objects and their corresponding identifying numbers are recorded in key mapping. And then system-generated identifiers are used. When a business partner is created in table BUT000, it's assigned a globally unique identifier, a GUID. In this example, you can see the 32-character GUID for business partner CU06. Every business partner in every system client has a unique GUID, except when a business partner is distributed from one client and created in another client by distribution. Then the GUID of the business partner in the source system is used for the business partner in the target system. The GUIDs are the same in this case. And that's an important point to remember as you look at and you manually maintain key mappings. For an example, let's look at business partner key mappings maintained for site business partner CU06 in two business systems. The first business system is S18 Client 100, and the second business system is S18 Client 200. These automatically created key mappings list the key numbers of the business partner objects in each business system. There are separate key mapping entries for the business partner, customer, and vendor. This example is for a store, so there is no vendor. Also notice that there are two entries for business partner, one for the business partner number and one for its GUID. But in key mapping, the entry is named Universally Unique ID, the UUID. Let's compare the GUID from table BUT000 with the UUID key mapping entry. Notice the difference in formatting. If you have to manually create key mapping entries, then you need to take values from BUT000 and format them accordingly before maintaining them in BP key mapping. In addition to providing mapping, the business partner key mapping entries are also the basis for controlling the site master distribution process. You'll hear more about that as the process unfolds. Armed with a conceptual understanding of business partner key mapping, let's walk through the steps of site master distribution. T-code DRF out is used to initiate each step. In the first step, outbound implementation 986.3 is used to distribute business partner, the master data. The first thing the system does is check key mapping entries in the source business system. It looks for key mapping entries for the business partner and target business system. If key mapping entries are found, then the system assumes that the business partner has already been distributed to the target business system. Therefore, it prepares a change message. If key mapping entries are not found, then the system assumes that the business partner has never been distributed to the target business system. Therefore, it prepares a create message. So that means, if the key mappings are missing or incorrect, then the wrong message may be sent. How could that happen? Well, let's say somebody manually creates the site business partner and the site in the target business system. Because the key mappings weren't created automatically as a consequence of site master distribution, the key mappings are missing, and a create message is sent when the site master distribution subsequently is attempted. But the create message will fail because the master data already exists in the target business system. In this case, you have to manually create the missing key mapping entries. This can also happen with system and client copies. After checking key mapping in the source business system, A replicate request message is sent from the source to the target. This is an XML message to replicate the business partner, the master data. When the message is received and processed, the target system sends a replicate confirmation message back to the source system. So you can see the distribution of the business partner was a two-way communication, a handshake. But that's not all. As the business partner messages were sent from each system, the business partner key mappings, like those we just looked at, were separately created in both business systems. In the second step, outbound implementation site out is used to distribute the retail site, the customizing. The first thing the system does is check key mapping entries in the target business system. It looks for key mapping entries for the business partner and the source business system. If the system doesn't find the business partner key mapping in the target business system, it'll refuse to distribute the retail site. This check enforces the sequence control. The business partner must be distributed before the retail site. If the system does find key mapping, then it distributes the retail site from the source to the target system via RFC. With that, the site master has been successfully distributed from the source to the target. Basically, for a known list of tables, rows of data are copied from source to target. Each business system includes key mappings for the business system that it communicates with. For example, when D41-100 sends to P41-500, then we expect key mappings for each business system to exist in each business system. In this example, the production system only ever receives from the development customizing system. It only has key mapping entries for those two business systems. On the other hand, the development customizing gold client is the source for all other business systems in the landscape. Therefore, the development customizing gold client will include key mapping entries for all target business systems. Let's do a quick demonstration of site master distribution. I'll use T-code DRFOut to distribute site CU08 from SE18 client 100 to client 200. Using WB03, we can see that site CU08 exists in client 100, but not in client 200. T-code DRFOut, choose a replication model, and outbound implementation 986.3. Click the manual replication filter criteria button, specify the business partner, then save. Now execute. No errors are displayed, and you should never believe this report. Instead, use T-code SRT Money in the source business system to look at the messages. For each business partner, remember the two messages are expected: replicate request and replicate confirmation. The confirmation message is a generally reliable indicator of errors if you drill down into the confirmation message. You can also execute SRT Money in the target business system to look at the messages. Again, for each business partner, we expect to see two messages. For distribution of business partner, SRT Money is usually my first step to check the result. If there were errors in processing, then in the target business system, check T-code SU53 for authorization failures for the SAP user ID associated with the web service. Next, check T-code SLG1 for application error messages. Now use T-code DRF out again for step 2. Choose a replication model, outbound implementation site out. Click the manual replication filter criteria button, specify the plant, then save. Now execute. No errors are displayed, but the report for this step is a more reliable indication of errors. For distribution of retail site, SRT money is not relevant. If there were errors in processing, then in the target business system, check T-code SU53 for authorization failures for the SAP user ID associated with the RFC destination. Next, check T-code SLG1 for application error messages. Using T-code WB03, we see that site CU08 now exists in the target business system. If the site business partner is distributed again, a change message instead of a create message, you'll see that the replicate request message is different. Notice that the message includes the BP UUID of the source business system, but also includes the receiver UUID. When both UUID are included, then this is a change message. When only the source UUID is included, the internal UUID, then it's a create message. It turns out that the monster of complexity can be tamed once you functionally understand the site master distribution process and the steps happening behind the scenes to control the process. Now take what you've learned and run with it.